Good morning students, welcome to DBS Talks. So now in this class we are discussing the subject is utilization of electrical energy. Okay, so in this subject today we are discussing about electric traction 2. Okay, so in electrical traction 2 in previous class we are discussing about the what are the types of services. Okay, so for explain those types of services we have to introduce the speed time curves. Okay, so the curves which are drawn in between the speed on y-axis and time in speed of the train on y-axis and time in seconds on the x-axis. So from that one you have to find out the how the train will be work depending upon speed time curves we have to discuss. Okay, so now in this class we have to analyze. Okay, so you have to simplify. Okay, you have to simplify that speed time curves. Okay, you have to simplify that speed time curves in the shapes of trapezoidal and quadrilateral. Those are called simplified trapezoidal and quadrilateral speed time curves. Okay, so simplified trapezoidal and quadrilateral speed time curves. Okay, so now in this class we are discussing about the simplified trapezoidal and quadrilateral speed time curves. Okay, see here simplified speed time curves. Okay, so the simplified speed time curves gives the relationship between acceleration, retardation, average speed and distance between the stop. Okay, which are needed to estimate the performance of a service at different schedule speeds. Okay, so the simplified speed terms gives the relationship among acceleration, retardation, average speed and distance between the stops. Okay, so why are you have to introduce these simplified speed time curves which are needed to estimate. Okay, to estimate the performance of the services. Services are nothing but suburban services, mainline services, urban services. Okay, so performance of a services at different schedule speeds. Okay, at different schedule speeds. Okay, so that the actual speed time curves for the mainline, urban and suburban services are approximated to some from of the simplified curves. Okay, so the actual speed time curves, okay, for the mainline services, urban services and suburban services are you have to discuss in previous class. Okay, those are approximated to some from the of the simplified speed time curves. Okay, so those are so in previous you have to say approximated, but now in this class you have simplified. Okay, so those are same related. Okay, these curve may be of either trapezoidal or quadrilateral shape. Okay, so these curves are in these simplified curves. Okay, are in a trapezoidal or in a quadrilateral shape. Okay, first we have to discussing about the analysis of trapezoidal speed time curve. Okay, so now we have to discussing the analysis of trapezoidal speed time curve. Okay, so first we have to go for the analysis of trapezoidal speed time curve. See here, trapezoidal speed time curve can be approximated from the actual speed time curves of different services. Okay, so trapezoidal speed time is approximated. Okay, it is approximated from the actual speed time curves of the different services. By assuming that here see the acceleration and retardation periods of the simplified curve is same to as the actual curve. So whenever you have to draw the simplified speed time curves, okay. So in simplified speed time, so speed time curves means the total speed time curve is divided into classified into 5 regions. Where no okay constant acceleration, okay acceleration speed bar acceleration or speed. Next one is free running period, coasting period, braking period. Okay, so the acceleration and retardation periods. Okay, so the acceleration and retardation periods of the simplified curve is kept same as that of actual curve. Okay, in simplified curves as well as in the actual curves, the acceleration and retardation periods are same. The running and coasting periods. Okay, so the running, free running and coasting periods of the actual speed time curve are replaced by the constant periods. Okay, so here in a trapezoidal speed time curve compared to the actual speed time curve, the running and coasting periods. Okay, so the running and coasting periods are replaced by the constant periods. Okay, this is known as trapezoidal approximation. So this is known as trapezoidal approximation. A simplified trapezoidal speed time curve is shown in. So this is the simplified trapezoidal speed time curve. Okay, so on x-axis we have to take the time in seconds, and on y-axis we have to take the speed in kilometer per hour. Okay, so this is the simplified. Okay, here this speed time curve is in the shape. Okay, here the simplified speed time curve is in the shape of trapezoidal. Okay, so that's why this is called simplified trapezoidal speed time curve. Okay, so simplified trapezoidal speed time curve. Okay, so on x-axis you have to take the time in second, and y-axis you have to take the speed in kilometer per hour. Okay. Okay, this is the maximum speed. Okay, so the maximum speed traveled by the train. Okay. Okay, so next you have to see the calculations from the trapezoidal speed time curve. Let d be the distance between the stops in kilometers. Okay, so this is the starting stop. Okay, receiving stop, ending stop. Okay, so the distance between these two stops will be, you have to assume that is will be d. Okay, so that is in kilometers. T be the actual running time of the train in second. T means actual time period. Okay, so for which time period the train will be running. So that time period will be assuming as T. T be the actual running time of the train in seconds, and alpha be the acceleration. Okay, here alpha is nothing but acceleration in kilometer per hour per second, and beta be the retardation. Alpha is be the acceleration and beta be the retardation in kilometer per hour per second. And here Vm. Vm be the maximum or crest speed of the train in kilometer per hour. Okay, here Vm be the maximum or crest speed of the train. Okay, maximum or crest speed of the train in kilometer per hour. Okay, so and Va be the average speed of the train in kilometer per hour. Okay, here Va be the average speed of the train in kilometer per hour. Okay, see here time for acceleration. Okay, time for acceleration. Okay, so here this is the up to T1, this is the accelerating period. Okay, that means gradually the train of the speed will be increases. So in that period, okay, so alpha be the acceleration in kilometer hour per second, and beta be the retardation in kilometer per. Retardation means to come to the stopping position, braking position. That time period will be called as the retardation, and Vm be the maximum or crest speed of the train in kilometer per hour, and Va be the average speed of the train in kilometer per hour. Okay, time for acceleration. So coming to the time for acceleration. Okay, so from here, from O point it will be starts, and whenever it will go to at the point A, at that time the train will attain the maximum speed. Okay, so at that time that time period is given by speed by, so time, how you can express the time period by speed by acceleration. So Vm minus 0. Here the train will start at 0 speed and gradually increases, and that speed value will be reaches to Vm. So at that time here you have to write Vm minus 0 by alpha. Okay, so it is T1 is written as Vm by alpha. Okay, so time for retardation. Retardation is nothing but T3. See here in T3 period. Okay, here the train will come to the rest position. Okay, braking position. So that is nothing but the T3. Okay, so that T3 value given by Vm minus 0 by beta, that is equal to Vm by beta. Here also, here Vm maximum speed, and coming to the whenever it rush to position, the speed will be 0. At that time Vm minus 0 by beta, and finally you can get Tvm by beta. Okay, so here we have to write. Okay, so total time period you have to write. Okay, T equal to T1 plus T2 plus T3. Okay, so total the time period of the train will be given by T equal to T1 plus T2 plus T3. Here we know that T1 value, T3 value. T1 value is Vm by alpha, and T3 value will be Vm by beta. So whenever you want T2 value, so at that time you have to write T2 equal to capital T minus of T1 plus T3. So capital T equal to T2 equal to capital T minus of T1 plus T3. T1 value will be Vm by alpha plus T3 value will be Vm by beta. So here directly you have to write. So this is the T2 value. T2 equal to T minus of T1 plus T3. T1 is nothing but Vm by alpha, and T3 is nothing but Vm by beta. Okay, so that means this is the time period for free running period. Okay, so T2 is nothing but it is the time for running period. The train along the running position, that is the time period to take and value is T2. Okay, so at that time here you have to get the T2 value is T minus of Vm by alpha plus Vm by beta. See here, area. So the area under the trapezoidal speed time curve gives the distance travelled, the total distance travelled between the two stops. Okay, so the area. Okay, so the area under the. Okay, so what is the area you have to get? See here, coming to the trapezoidal speed time curves. Okay, so this is the trapezoidal speed time curve. So the area. Okay, so what is the area you have to get under this trapezoidal curve? The total area is nothing but the distance travelled by the train. Okay, that is the total distance travelled by the train. That is you have to assume previously d. Okay, so here area under the trapezoidal speed time curve gives the total distance between the two stops is d. Okay, see here the distance between the stops d equal to area under triangle OAE plus area of rectangle ABDE plus area of triangle DBC. So here, see here, you calculate D value. So D is nothing but the area under the trapezoidal curve. So this is the area. So in this area here, this is in the triangle form. Okay, this is in the form of rectangular and this is also in the form of triangle. Okay, whenever you want the total area under the trapezoidal curve, the total area is equal to the distance travelled by the train. Okay, so the total distance travelled by the train. So to find out the area, here you have to write sum of the area of the triangle OAE plus the area of triangle ABED plus the area of triangle BDC. Okay, so here you have to write the area of triangle OAE plus, okay, the area of triangle, the area of rectangle ABED plus the area of the triangle BDC. Okay. Okay, DBC. So, so here coming to the area under the triangle OAE, that is nothing but the distance travelled during acceleration. OAE triangle under the period of accelerating period. Okay, so at that time that is equal to the distance travelled during the acceleration plus area of rectangle means that is nothing but free running period. Okay, so the distance travelled by the train during the free running period plus distance travelled during free running period plus distance travelled during retardation. Okay, area of triangle DBC means this is the triangle. So here the train will comes to the rest position. Okay, so that is nothing but the distance travelled during the retardation position. Okay, so those are nothing but so here the distance between the stops is equal to area under the triangle OAE plus area of rectangle ABDE plus area of triangle DBC. So here, so area of the triangle OA is nothing but the distance travelled during acceleration plus the distance travelled during free running period plus the distance travelled during retardation. Okay, see here the distance travelled during acceleration period. Accelerating period, the distance travelled. Okay, C is nothing but average speed during accelerating period into time for acceleration. Okay, so the distance travelled during acceleration means the average speed. Okay, that means you have to take the speed average. Okay, starting you have to 0 and whenever the train will comes to point A, whenever you have to see in trapezoidal speed time curve, whenever the point will reaches the point A, so at that time it attains the maximum speed. Okay, so at that time you have to take the average of the speed. So at that time it will become 0 plus Vm by 2. Okay, so this distance is nothing but speed into time. Okay, so our speed equal to distance by time. Okay, so from this formula distance equal to speed into time. So that average distance is given by 0 plus Vm by 2 into T1 kilometer hour per second. Okay, time for acceleration T1. Okay, so at that time 0 plus Vm by 2 into, so here you have to kilometer per hour per second. You have to convert this kilometer. Okay, per hour you have to write 3600 seconds. Okay, T1 by kilometers. Okay, this is That means here, so the total distance between the stops is equal to the distance during acceleration, distance traveled during free running period plus distance traveled during retardation. Okay, so that's why here you have to first find out the distance traveled during acceleration, next one the distance traveled during free running period, next one the distance traveled during retardation. Okay, by adding these three, here you have to get the by adding these three, you have to get the total distance traveled. So first here you have to write the distance traveled during the accelerating period. Okay, so that will you have to get, okay, Vm T1 Vm by 2 into T1 by 3600 kilometers. Okay, so next the distance traveled during free running period, that is equal to average speed into time for free running. So in free running period, okay, it will maintain a constant speed, okay, maximum speed, that is nothing but Vm. Okay, so whenever you have to see trapezoidal speed time curve, okay, so this is the free running period. Okay, so this in the free running period, this will be travels with a speed Vm, and the time for the free running period is T2 seconds. Okay, so at that time here you have to written as, okay, so Vm into T2 kilometer per hour per second. Okay, so whenever you have to convert that hour per second into kilometer per hour, you have to write 3600 seconds. So at that time it will be written as Vm into T2 by 3600 kilometer. Okay, so this is the distance traveled during free running period. Okay, so next here you have to write the distance traveled during retardation period. Okay, so what is the distance traveled during retardation period? That is equal to average speed into time for retardation. Okay, so whenever you have to write, okay, so average speed Vm plus 0, this is also okay. So whenever, so after a free running period, the train will comes to the retardation position. So from free running to retardation, in free running here the train travels with the speed will be Vm. Okay, from that Vm it will coming to the retardation and finally will comes to the rest position. Retardation means braking. We are applying the braking, that means the train will comes to the rest position. So at that time Vm plus 0 by 2 into T3 kilometer per hour per second. Okay, so this is the average, that is the speed distance traveled during which period? Retardation period. Okay, so here also same, you have to convert this kilometer hour per second into the kilometers. So Vm by 2 into T3 by 3600 kilometers. Okay, finally you have to add. Okay, so finally we have to add this all the three distances traveled. At that time you have to get the distance between the two stops. Okay, so here the distance between the two stops is D equal to, so first one, distance traveled during acceleration period, that is you have to get in previous slide Vm by 2 into T1 by 3600 plus, okay, the distance traveled during the free running period. Okay, so here the distance traveled during the free running period is given by Vm into T2 by 3600. Okay, so here the distance traveled during the retardation. Okay, during the retardation the distance traveled is given by Vm by 2 into T3 by 3600. Okay, so here in all terms you have to 3600. Okay, so whenever you have to put 3600 here, so at that time it will get 3600D. So at that time this will get Vm T1 by 2 plus Vm T2 plus Vm T3 by 2. Okay, solving the quadratic, so at that time this will be comes into a quadratic position. Okay, so whenever you have to solving the quadratic equation, so whenever you have to simplify this total this equation, so at that time here you can get the Vm square x minus Vmt plus 3600D. Okay, by solving this equation, okay, by solving this quadratic equation, so by solving this equation you can get the quadratic equation is this one. What is that one? Vm square x minus Vmt plus 3600D equal to 0. So why you can get this equation is, now here you have to see. So first D equal to, so here D equal to Vmt1 by, so 3600 into 2. So it will become 7200. Okay, so at that time you can write Vm T1 by 7200 plus Vm by, see here, Vm by Vm by 3600 T2. Previously, I will say that the total time period for the train T equal to T1 plus T2 plus T3. Whenever you want to T2, so at the time here you have to write T2 equal to capital T minus of T1 plus T3. So initially here you have to write. So that's one that is here you have to apply. Okay. So that will becomes okay Vm of here only, so here there is no Vm. Okay, this is mistake. T minus of T1 plus T2 plus Vm by T3 7200. Okay, here Vm T3 here, so 3600 2s are 7200. Here there is no Vm. Okay, so this is a mistake. Okay, so here there is no Vm. Okay, so here in the place of T2 we have to write T minus of T1 plus T3. So here Vm by 7200 alpha, that means okay. So in previously at first you have to get T1 is nothing but Vm by alpha. So at the time Vm into Vm by alpha, that will becomes Vm square by 7200 alpha. So here plus Vm 3600 T minus half. So here T1 is nothing but Vm by alpha. So previously first in trapezoidal speed time curve you have to write T1 is nothing but Vm by alpha plus T3. T3 is nothing but here also T3. Okay, this is also mistake T1 plus T3. Here in the place of T2 you have to write capital T minus of T1 plus T3. T3 is nothing but Vm by beta. So at that time here you have to common Vm 1 by alpha plus 1 by beta plus here also T3 is nothing but Vm by beta. So whenever you have to write Vm by beta, Vm by 7200 into Vm by beta. So at that time it will becomes Vm square by 7200 beta. Okay, so at that time here okay, see here coming to this denominator, in all terms you have to 3600. Okay, so this is written as 2 into 3600, here also 3600, here also 2 into 3600. So at that time this 3600 write this side. Okay, so whenever you have to write this 3600 this side, so at that time it will becomes 3600 into d, that is equal to, at the time here only you have to 2 Vm square by 2 alpha plus here also Vm square by 2 beta. Here you have to write. So here you have to multiplying with Vm into t, so this will becomes Vm into t right here. So here Vm into Vm will becomes minus Vm square 1 by alpha plus 1 by beta. Okay, so at that time here you have to common 1 by V, so we have to multiplying with this Vm square and split here, minus Vm square 1 by alpha minus Vm square 1 by beta. So at that time here you have to common Vm square, you have to write alpha term separate and beta term separate. So here also Vm square by 2 alpha minus Vm square by alpha. So at that time here you have to common Vm square 1 by 2 alpha minus 1 by alpha plus Vm square, you have to common beta terms 1 by beta, here also 2 beta. Okay, this is also mistake. Vm 1 by 2 beta minus 1 by beta plus Vm into t. Okay, so at that time here you can get, whenever you have to take LCM, at that time here you have to get the minus alpha by 2 alpha square. So at that time it will becomes minus Vm square by 2 alpha. This will becomes minus Vm square by 2 beta plus Vm into t. Okay, so here in these two terms, whenever you have to common the minus Vm square common, so at that time it will becomes 1 by 2 alpha plus 1 by 2 beta plus Vmt. So at that time these are all terms right this side. So at that time this equation will becomes Vm square of 1 by 2 alpha plus 1 by 2 beta minus Vmt plus 3600 into d, that is equal to 0. So here this total term 1 by 2 alpha plus 1 by 2 beta is equal to, you have to assume that is a one coefficient, okay, constant term, that is you can assume here x. Okay, so whenever you have to take LCM, this will becomes 2 alpha beta, here alpha plus beta by 2 alpha beta. Okay, this is the x value. So in the place of here 1 by 2 alpha plus 1 by 2 beta, here you have to assume x. Okay, that is written here. So at that time this equation, this above equation will become Vm square x minus Vmt plus 3600 d equal to 0. Okay, this is looks like a one quadratic equation. Okay, a square, okay, quadratic equation. Okay, so by solving this quadratic equation, okay, so by solving this quadratic equation, you can get roots. Okay, whenever you can solve any quadratic equation, here you can get the roots. Okay, so at that time that Vm value will becomes, okay, t plus or minus. So what is the formula for a quarter to get the quarter minus b, plus or minus square root of b square minus 4ac by 2a. Okay, this is the formula for getting the quadratic equation. Minus b, in the place of minus b, here in the place of you have minus Vm. So in the formula already you have to minus t here. Okay, minus t. So at that time in the place of minus into minus t plus or minus, in the place of b here you have to t square minus 4a. In the place of a here we have to s, and ac in the c constant, in the place of c 3600 d by 2a, 2 into x. So at that time it has written as t by 2x plus or minus, you have to split. Okay, so this is right in the root 2x. So at that time it will become t square by 4x square minus 3000 d by x. Okay, and here x, so it will comes to the root, it will become x square x cancel. So at that time the Vm value will become t by 2x plus or minus square root of t square by 4x square minus 3600 d by x. So always you have to see here, by considering the positive sign you will get the high values of crest speed, which is practically not possible. So here you have to can get the root two values, plus value, minus value. So whenever you have to consider, so if suppose we have to consider the positive values, so whenever you have to get considering the positive sign, at that time you will get the high value of crest speed. So but it is not practically possible. Okay, so that's why here always you have to choose, select the negative sign value. Okay, so at that time you have, whenever you have to choose the negative sign, so at that time that value will become Vm equal to t by 2x minus square root of t square by 4x square minus 3600 x d by x. Okay, this is the Vm value. But here x means alpha plus beta by 2 alpha beta. So whenever you have to write here, you have to substitute x value in this equation. So t by 2 of alpha plus beta by 2 alpha beta. 2 alpha beta means 2 will be cancelled, alpha plus beta by alpha. So whenever this is in a denominator you have to reverse. So at that time you can get alpha beta by alpha plus beta into t minus t square by 4. Okay, here also x square means alpha plus beta by 2 alpha beta square. 2 square means 4 cancel. So finally here you can get alpha beta by alpha plus beta whole square t square. Okay, t square minus, here also x means alpha plus beta by 2 alpha beta. Okay, so whenever it will goes to numerator, so at that time it is multiplying with 2, so at that time it will becomes minus 7200 alpha beta by alpha plus beta into d. Okay, so this is the speed, okay, the maximum speed attained by the train. Okay, so formula, okay, and this is the formula for distance traveled by the train. Okay, that is the distance between these two stops is find out by using this formula or by using any this formula. Okay, so and this is the formula to find out the maximum speed. Okay, the maximum speed attained by the train. Okay, so so now in this class we are discussing the analysis of the trapezoidal speed time curve. Okay, so that means it is the simplified Okay, so it is the simplified form of the actual speed time curve. Okay, so from that one, here we have to so by whenever you have to simplify the actual speed time curve, so here only you have three periods. Those are accelerating period, free running period, retardation period. Okay, by using these two periods, this under the area under this trapezoidal curve. Okay, so by using the area under the trapezoidal curve, only you have to find out the total. Okay, so the total distance traveled by the train. Okay, so by using that one, and you have to find out the maximum speed attained by the train. Okay, so in the next class we are discussing about the analysis of the simplified speed time curve. Okay, see, this is also same. Okay, simplified quadrilateral speed time curve. Okay, so the quadrilateral speed time curve is also same as trapezoidal speed time curve, but only different is in the shape. Okay, so quadrilateral shape. Okay, so that's why this is called the quadrilateral speed time curve. Okay. Okay, next class we are discussing the quadrilateral speed time curve. Okay, thank you.